Hello guys, good morning. I just woken up. Maybe I should put it like this. You can see me. You're seeing the back there. There's a wire over there. So it actually I'm in this room, which way against the light here. You can see my face clearly. I woken up. I just want to give you some video today. Swallow some water. This is a room. Yeah, I'm doing this video where I stay. Actually, I'm staying here. Yeah. I just want to give you. So it's dark. In this room where I just woke up, the lighting here is very good here. Maybe I should have done this video from here. Look, there's a bed where I woke up. Can you see me properly? It's actually a totally filled room. Maybe I should put it like this, guys. Now today, I want to show you something about home. Yeah, you know I got it. It's quite clear here. Now, ohm resistor, ohm and voltage analysis, right? Let me just check what I'm saying this. Now here you see me against the camera clear. When I turn like this, guys, look dark, right? This against the light looks good. So I want to show you some experiments, and of course, wait a minute, hold on a minute. I'm holding the camera with my hand, so that's why you see my head sometimes protruding. It's quite complicated experiment, and it's about home. This light we use in the house, one guy called Ohm came up with it. A scientist, right? It's called Ohm's law, and it's about circuit analysis, right? And what did he say, or what did he discover? Yeah, guys, I sometimes feel like giving a room tour before to animate this video. Like show you where I stay outside. Maybe this could be something good. Let me show you. That's outside. I'm turning the camera. You see where I'm staying. It's a dirty clothes, right? All the way there. Guys, sleeping. This is a tank over there. So actually, guys, you don't know that I shoot a video. So that's why I'm a bit nervous that I'm showing you quickly. You guys are asleep here because time now is 8:30, 8:40 in the morning. So away from these shenanigans, what do you call it? This beating about the bush. The thing that I want to show you today is ohms. And what does Ohm say in this circuit analysis? Ohm says voltage V is equal IR. I stands for current, R stands for resistance, where V is voltage, right? And I is current, and R is resistance, which is measured in ohms. His name may probably his name because you know these things are named after the discoverers. So his name must have been Ohm. I am not sure about it, but I guess his name may have been Ohm. So Ohm law allows you to determine characteristics of a circuit, such as how much current is flowing through it, if you know the voltage of the battery in the circuit and how much resistance is in the circuit. So if you are saying voltage is equal IR, it means you can calculate how much is R, right? How much is I. The simplest way to do it is like if you want to determine I, then you are going to divide R in both sides. Then R and R will cancel. Then it will be V over R. So current will be current will be what? Will be voltage over resistance when you calculate it, or resistance will be voltage over current. You divide I in both sides. That's mathematical. For those, I think, guys who follow me really may be having a background in maths. And what is the Ohm's law of short circuit? You have heard of short circuit and so on. So that's not the main thing. First we'll talk about that, and I've just made some experiment here to analyze this. Unfortunately, I had to do it off camera because the circuit connection is a bit complicated and I don't have a cameraman. I'm just going to show you, turn the camera. I'm going to turn the camera around. You guys, you are going to see this experiment, okay? Don't mind about this, the shelf where we keep stuff, you know. This is like a sitting room come kitchen here, I think. I should say so, because there's a bedroom is over there where I took you. Yeah. Okay. So now I'm showing you. I'm going to turn the camera so you see the connection. I think you don't want to see my face anymore. You want to see what I want to tell you about Ohms circuit analysis. Okay. I'm turning the camera, guys. Hold on a minute. We are continuing. I had to turn the camera. I think there's no technicalities of turning the camera. I have to put it off. And I have to apologize for that. So you can see now I've connected this circuit. It's quite complex. There it's showing you 1.6 volt, 1.60 actually volts. I've used these things are quite delicate, so I don't know how I can deal with it. You see, this is a jumper wire which is connected to the top of this resistor where my hand is pointing, top of it, and I have another jumper wire here which is connected to the bottom of this R2 resistor. This is R2 and that one is R1. So I'm measuring just this R2 and it's showing me is 1.61 volts. Okay, and this is my voltmeter that I'm used. I've tied with the tape here to connect to these wires, which I've connected jumper wires. The jumper wires I've used because they connected well with this breadboard. This is most important because it has to take correct current from here, voltage from here. Now this white wire which you are seeing, my hand is touched. This one is going to the 5 volts of the Arduino here. And then the red wire, which is this one, is going to the ground in the Arduino. It's going to the ground where my finger is pointing. So it's connecting the top of our I've connected the top of R2. So when I'm taking the entire 5 volts, all I need to do will be, I'll have to take this. Of course, I've now shown you R2, how to measure R2. Of course, I've shown you this one, which is connected to this wire of the COM. This is the COM side of the multimeter here. This is the COM side, and this red one is connected to the 5 volts. 5 volts. 5 volts. Yeah, the down leg of the resistor 2 here. Okay, and it's giving us the resistance of this resistor 2. The ground is there. Now let me connect. Let's try to determine what is this one. And I want to take this wire to the bottom. I guess the bottom of that, right? No, this one I take at the top, not the bottom. Sorry guys, I take the top of yeah, R2. I put there at the top of R1, the leg of R1 here. It's putting some current through me here. I'm taking some voltage, guys. If you subscribe to my channel, I'm risking a lot here, taking some voltages. Some electrons are being drawn from my body. Now I'm taking this one, which I connect to the top of R2, down to R1. Okay, right? So you can see I put this one here, and this one I'm connecting this COM, the bottom of R1, and this ground, this one top of R1 there, and here it's giving you 340. Okay, it's giving 340. Now it's simple arithmetic. 160 plus 340 is 505, and we are having 5 volts from Arduino. Is quite accurate actually. You see what is coming out of that Arduino is 5 volts, and here this resistor is a 450 ohm resistor. That's what I could have, but the recommended one will be 330 or 350. 330 voltage, ohms resistor. 330 ohm resistor would be recommended, and some maybe like 100 resistor. That is perfect for this as well. But what I have here is a 450 ohm resistor, this one down there, which is a blue green ceramic coating, and this one with the red coating ceramic, which is R2, is about 200 volts. Ohms, sorry, I confuse ohm and volt. Volt is the electric current push. The pressure is what we call volts. Okay. So now I measured the down one, R1, by putting this here. My finger is shaking, guys. And the other one down, because I'm feeling, wow, anything can go wrong here. I see it's quite complicated in this one. These are put the R2, that's pin port 20 of the breadboard. Down below R2, R1, I put this jumper wire which connects to the ground. Here, this one which goes to COM to measure what we are measuring here, right? And I put this one on top of R1 here. This is connected to the red wire, this one, which goes to the voltage side of the voltmeter, right? Voltmeter. Don't mind English as a second language, guys. Sometimes I mix terms. So there it is shown now. Let me see. Can you see it? Yeah, it's written V ohms or MA milliamps. So there's a reading here on this thing. Oh, now you are seeing my finger. I'm just pointing the red one, the red stuff. This is what is measuring the voltage, and that one is measuring. This is going to ground. This pin which I've connected in the Arduino, the red one. This one is going to the ground, and I've connected it here. Loosely connected it, very loosely, because otherwise it can go off, and it's very difficult to connect it. When it goes off here, it will read 0, and I don't want to do that, because then you'll go off camera. Okay, and now I'm going to show you another one now, total, and how to do this is to bring this one now down. You can see what I'm doing. I'm removing this here, and I'm putting somewhere in the middle here on the top of R2. Okay, top of R2, and that one is right there. It's taking 5 volts. You know, all these things are electrically connected together in columns. All these 5 there are 5 columns. They go like this. They're connected together, and if you are on the rails, then it's horizontally connected. So here you can see we are taking 5 volts here, which comes from the Arduino there, 5 volts there, and then see what the reading is. 5.0, very accurate. We can ignore the impedance, the resistance of other It seems that Arduino is giving us slightly more than 5 volts. Slightly more. But if you take approximations, because you convert 3 is negligible. It's negligible, you know, so it's actually 5 volts in total that is coming out of that. What you're actually reading here with the voltmeter here. And it's quite accurate. There's no doubt about it. That's the total, that's voltage that we are getting. Okay. So this is circuit analysis of this ohm. And maybe I have not drawn a diagram. Maybe I'll do part 2 of this video. Then I'll show you a diagram. But you can also construct it if you are an engineering person. You can easily construct this diagram by seeing where the voltage is 5V comes from, which is there. 5V is coming from there. And then it's going through the resistance there. So you draw the diagram, a round circle, 5V plus minus, then like a rectangle going. It go to resistor. It's in series, by the way. This resistance is in series. It's not parallel resistance. Series in the sense that it just follows one line up to this point. Okay. Now that's it, guys. That is what we call Ohms circuit analysis. I'm sorry that I cannot do it off the camera because I have a cameraman. Then I'll be able to show you one by one how to connect this thing one by one. But now, since I have only 2 hands, I always tell you I have only 2 hands. There's not much I can do, man. Now you can take the circuit. Let me see whether I'm having it here by chance. No, this one I'm afraid of camera. Now 1 minute, guys, 1 minute. I'm sorry that this thing has to shake around. And you can see in this diagram, but I don't know what mathematically you can see. This I've used 450 ohm resistor, right? Here, which I'll call R1. No, actually total resistance. This one, I've taken to the wrong one here. This is like when you're doing the one complete without having two resistors there. Now this is where we're having 2 resistors, and this one I used 450, and here I've used 200 ohm and 450, right? Yeah. So yeah, this is what I'm having there, because I do not have the recommended one for this type of experiment. So this is a current. You know what goes through here is a current. You can calculate the current. Current is equal to what? V over R. Voltage over resistance, the formula is up there. I think I've calculated somewhere here. You can see current is equal to V over R. And if you have the voltage is 5, let's say voltage is 5 volts. Actually it's 5, and resistance, total resistance is what? If you are giving total resistance is around 650 here. I'm saying around because I'm not sure. Add a 0, add another 0, then bring a 0, then cancel the zeros, bring another 0, I think, bring another one, then 8, no, 6 times 6, 6 times 7, 6 times 8, no, I think this is not correct. I mean, it's mathematical. You can see the formula. If you are an engineering student, you know how to calculate. For example, current is V over R, and V voltage, so current times resistance. Okay, so it depends what you want to calculate and what you have. For example, if you want to calculate resistance, then resistance, then you divide by 1. over 1. See what I'm doing? This and that will cancel, so you'll have resistance equal V over I. Now resistance will be equal to V, voltage, over resistance. What is that? Over current. You are calculating resistance. We were divided by current both sides, so current and current will cancel, so you are left with R, which is resistance. Turning the other way around, like this is resistance. Handwriting, guys, you have to forgive my handwriting. Is R. This resistance, total resistance will be equal to voltage over current. And if you don't know the current, then you have to multiply by 1 both sides, by 1, and the 1 will cancel, and then you have 1 R is equals to V. Now you want to know the current, then you divide by R, and they divide by R here, the R and R will cancel. So now here you'll be left current in amperes, by the way, milliamps, not yeah, will be equal to voltage. In our case, voltage is 5 over resistance. Now from this formula you can calculate resistance to 1. For example, 450 ohm. Here current will be, what will be the current? Will be voltage here is 450. Sorry, we don't know. The total voltage is 5, and the resistance 1 is we said 430 or 450. Let's say 430 ohm resistor. Then now this one you can divide and get the answer. Similarly, you can do for R2. Okay, and I've done this some maths here, so I'm trying to show you circuit analysis, guys. You gotta see this. Resistance R1 plus series resistor, I've written there. See, series resistor. Resistance R1 plus R2. That means it's gonna give you total resistance. This I use the right one, 330, but I don't have this. I have 4. In my case, I have 430. Say I have 430 and I have 200 here. I have 430 and 200. So in nutshell, it's gonna be 630 ohm. That's the total resistance. Okay. I don't know whether you are seeing this. Yeah, 630 ohm total resistance, because the formula is that resistance is resistance 1 plus resistance 2, which I showed you here. This one, this is 430 ohm resistor. Oh, camera, it's not doing justice here. I'm moving it around a lot, it can just go off, you know. Yeah, let me point with the pen here. This one, this is resistor 1, this is resistor 2, which I'm showing you in the maths, and the total of these two is about 630 ohm resistor, and we have a current of, but I think I have the feeling that Arduino is giving slightly more, because we have 5.03 or something like that, but let's say 5, so it will be 5 over 650. 5 over 650, guys. I'm calculating at the same time showing you. It's quite complicated. Yeah, man. Okay, so let's go with the diagrams, guys. You know, come on, that is 5 volts. The current is there. Oh, it can't be like this, you know. Just this is an assumption I'm making. So let me really calculate it mathematically here, what we are really actually having. That's a laptop over there where I've connected the Arduino. So I'm gonna do this. Voltage is equal to current and resistance. Okay, is this a formula? Maybe I need to bring the calculator as well. Let me bring the calculator, guys. Sorry, this is not part of the video. I'm just bringing this from the bed where I've slept. This is the tablet. it has the calculation. Because I'm using the smartphone to shoot this video, I'm putting it on. Yeah, so I'm putting it on. Yeah, okay, let's wait a minute. We're going to do the actual calculation of this voltage analysis, and I use this lens also to measure this thing. Okay, 1 minute, I have to open it. This thing is locked, sorry, it has a lock. I've locked it, so now it's open. I'm going to calculate. That's why I'm looking for a calculator. Yeah, now I got in a calculator. Yeah, the calculator and the tablet. So that's the one we are going to use to calculate now. I don't know where I took the pen, guys. Oh man, I've lost the pen. Yeah, here it is. Don't worry, I'm moving around because I'm the cameraman, I'm the film, the person who's doing the film. So here, voltage. First of all, let's say resistance. We said that the resistance equal to resistance 1 and plus resistance 2. Okay, so resistance, total resistance will be 450 plus 200, for example, but I said 430, right? So resistance will be 630 ohms resistance. Now, from this formula up here, mathematically, we're going to calculate anything we want to calculate. Suppose we want to calculate the current, and we know voltage is equal to current times resistance. Okay, what do? We divide by resistance in both sides. Okay, mathematically, when you are doing like this, it means you have to cancel this, and now you are left with voltage over resistance equal to current. Turning the other way around, it will be current is equal to voltage over resistance. Okay, I don't know what they are seeing, these guys, the maths. Now, if you go this way, total voltage we have in 5 volts. Okay, and the total resistance we have in 630. Okay, now you have to divide these two, and I have a calculator here. That's why I put on this thing. I'm going to calculate 5 divided by 630 is equals to not really very accurate. This is what you have gotten as an answer, and 0.079, this is the answer we got. Now this one you have to turn in amps to milliamps. You have to multiply this times 1000. Let's do that. 1 2 3. This means what are we calculating? Current is should be like this. Mathematically, I'm just trying to show you. It's come to 7.9. That means 8 milliamps are flowing through that stuff over there. We are not going to measure that right now. In future videos, I'll show you how to calculate, measure current through this. Okay, this is, by the way, we are doing DC, not phase. Phase is that we have turned to direct, not phase. I don't know what the accent, my accent, you are getting it because this typical Kenyan English. So here I've shown you. So suppose you want to calculate voltage now. You can see from the maths above. These maths I've shown you. I don't know how to put the camera, guys, so that you can see. And okay, let me do this. Let me utilize this part. We have said current is equal to V over R. So now we want to calculate voltage. We multiply both sides by R. See what I'm doing mathematically? So if you do this, it means this and this will cancel, and we have for R current is equal to voltage, right? In other words, voltage is equal to, turning the other way around, current times resistance. Okay, and for this, you know, already we have determined this to be around 8 milliamps times total voltage. Voltage is 5. No, what we got actually was 0 point something, sorry. Yeah, we got 0.0079 something times 630, for example, right? Yeah, that's on 630. Now you get out your calculators, and then there's a -3 at the end of this, so we can actually, like, we don't have to do much. Let me see. Okay, let me do 0.0079 times 630. It is like approximation because we're not very sure. Yeah, you can see actually, guys, you really almost nailed it. See, 4.977 volts. Almost correct, because if you round up 9, then it would be 5. It would be 5 is equal to 5V voltage. So we are actually very, very correct. Maths never lie, you know. If you multiply these two, you get 5 volts. Okay, guys, so yeah, this is our Ohm determine these things. So I don't know whether I should read you a bit about it. What's the definition of a voltage? I've written some notes for you. Voltage, also called electromotive force, is a quantitative expression of the potential difference in charge between 2 points in an electrical field. Voltage. But voltage is also known as electric pressure. It's pressure. It's also known as electric pressure. Yeah, let me put here, as I'm telling you this stuff, so you'll be seeing that this experiment, which is there, Arduino is blinking over there. The 5 volts we have is just negligence. That is impedance, is the resistance, the reactance, and all that. I don't know what the Arduino is giving from there. It seems to be giving more than 5. And these are our multimeter, voltmeter, the breadboard, the jumper wires, the circuitry. We have the resistance 1, the resistance 2. Yeah, pretty much. And that's connected to the laptop. So here I was telling you what is voltage. Voltage is also known as electric pressure, electric tension, or potential difference, which is the difference in electric potential between 2 points. In static electric field, it corresponds to the work needed by unit of charge to move a positive test charge from the first point to the second point. So that's another definition of it. Now let's talk about the current. What is current? A current is a flow of electricity, which is a result from the ordered directional movement of electrically charged particles. This completes the circuit so that a current flows to the lamp or the light or whatever the appliance is. And then what is the resistance of a wire? Resistance is the property of a conductor by which it opposes the flow of current through it. It resists it. It's a resistant. It opposes it. It's determined by the relationship between the applied voltage and the electric current passing through it. Those are the 3 things that I showed you here, which I'm trying to tell you. Okay? That's V is equal to IR. V stands for voltage. This is an operator, equal sign in mathematics. I don't know whether you know it. It means this is the same as equivalent to this. It's equal to this. Now this is current and this is resistance. If you multiply these two, they'll give you this answer, this voltage. And that's what I did here. I did it here. Where is that? Here. And we got 4.99. There's of course impedance, reactance, inductance, so in between, but the fair approximation is actually 5, because if you get 4.977, that if you round that up, it will come to 5 volts. Okay, so this is completely accurate maths, and it concurs with what I've done here. You can see that one is giving 5.0, that's total, and of course marginal errors are there, and it's flowing through these wires. So but if you round it up, it's actually 5 volts. Yeah, man. Okay, I'm gonna turn the camera third time around. Guys, thanks for watching. I will go by the name Victoria on YouTube. Please, you can check me out there. Yeah, and we are done the experiment today. Yeah, please subscribe to my channel, like and share and comment. Yeah, maybe I need to remove my glasses for once so that you can see me without glasses. Yeah, man. Please, I'm asking you to subscribe to my channel, right? Because if you don't subscribe, then this channel will not grow, and sure one day it will die. If you are not predicting doom for it, I'm saying it should go on, and it can only go on with your effort, right? With your contribution. You don't just watch and go. I see a lot of views in my channel, but nil subscription. For my Indian audience, kiale wai, avi me Kenya bonjiga Kenya beta na ye me video pa now. Please subscribe, karo, watch, share, and comment. ठीक है? My दोस्त ये गांधी नगर वाला क्या हाल है? अभी Kenya beta यार. ठीक है? सब ठीक हो? Bye यार. I miss you guys. Okay, enough for today. See you in the next one. Bye. Ciao. This can look like a thumbnail. I'm holding the camera with my hand. The guy is shaking. Yeah? Bye.